look at the recycle one. What is the mass flow of xylene in this stream? 168.83. You want 200 kilograms of xylene to close the loop. You need to add makeup amount, 200 minus this. How do you do that? That's why you need a Fortran block. Look at the Fortran block. Under flow sheet option, calculator C1. Makeup 1 is the mass flow rate of this makeup stream. CW, okay, look at the define. Design spec. No, calculator, not the calculator, sorry, input. Makeup 1, mass flow makeup stream, component xylene. RECYCl, that refers to the xylene flow rate in this outlet stream. How do you determine makeup? That's what this calculator does. Calculate makeup 1 is 200 minus RECYCl. Now, after you have minimized the open loop, this 200 is no longer valid. Could be 120, 130, 140 is your number. You need to change this to the final xylene flow rate in the open loop. Sequence. Once you know xylene flow rate in the recycle stream, RECYCl, you find out makeup. That is this. So, you close the loop. What is the next step? Here, you need to take care of the process safety. ACN, look at the result temperature, 21.4 degrees. The flash temperature is 5.5 degrees. You must cool this below the flash temperature. TOL coming out 110 degrees. Flash temperature of TOL is 4 degrees C, 4.5 something. You need to cool this down to 4 degrees C. Waste stream contains xylene and other components. Assuming the waste stream has the flash temperature of xylene, then the flash temperature about 27 degrees C. You must cool the stream. Look at the stream right now. It's the same as input, 138. You want to cool that down to 27 degrees. So you have the task of safety cooling. That is the next step. Now, your handout, safety cooling. Cooling water, 35 to 45. MEK minus 29 to minus 19. High pressure steam, 1034 kPa. That is for the secondary boiler. Low pressure steam, 172 kPa for the first boiler. You want to cool ACN product, (21 degrees to 5 degrees C. You cannot use cooling water. So when you add a heat exchanger, the coolant is MEK. That goes from minus 29 to minus 19. What is the mass flow rate of MEK you need? It's the same as this, except now, in this heat exchanger is specified. Look at here, what do you specify? Hot stream outlet temperature instead of vapor fraction, 4 degrees C. 5 degrees C, 4 degrees C, 27 degrees C. You want to cool that down. What is the mass flow rate of MEK you need for this heat exchanger using a design spec the same as this? Now the trouble with TOL is, you look at today's handout, you need two-step cooling. 110, cool it down to 45. Cooling water comes in 35 to 45. There's a 10 degrees C delta T mean on this side. You cannot cool it down below 45 because it requires delta T mean of 10 degrees C. In this case, you're cooling water, followed by another cooling exchanger from 45 to 4 degrees C. Here you need to use MEK, minus 29 to minus 19. What is the flow rate of cooling water MEK? Use design spec, and I have this file, two-step cooling, right here. Two-step cooling, all right? So look at here, cooling water 35 to 45. This heat exchanger, input, hot stream outlet temperature 45. Now, you method. You look at this cooling water, and I give you a handout about heuristic. I think that is in, let me see. Aspen training folder, right here, long time ago. Heuristic. Okay, come down. When you choose heuristic for heat exchanger, heat transfer between water and TOL, water to liquid, 0.85. Condenser, 0.85. Liquid to liquid, MEK to TOL, both are liquid, 0.28. You notice? 0.28. Reboiler 1.14, always unit kilowatt meter square degree C. You should, I will check your simulation, making sure you have used the correct heat transfer coefficient for sizing exchanger, simulating exchanger. So now come back to the simulation file, two-step cooling. This is the first one. The second one, you look at here, input, hot stream outlet temperature 4 degrees. TOL has a fresh temperature of 5 degrees. So cooler below the fresh temperature. What method do you use? 0.85. water and liquid is 0.28. Liquid is 0.85. Watch out. So, what is the cooling water flow you need? MEK flow rate you need? I have two design specs here. Okay? The first one determine the cooling water flow rate. Outlet temperature is 45. By varying the inlet temperature. The second one, MEK, outlet temperature minus 19, vary the inlet temperature, inlet flow rate. So, you apply the two-step cooling also to the waste stream. So, the next step, you need to size the condenser reboiler. Become familiar with the use of pseudo stream. Proceed to size condenser reboiler for both columns, following the Class A-now simulation example. Let's open one example. In the condenser reboiler, okay. Yeah, condenser reboiler sizing. Condenser sizing, reboiler sizing. There is a complete handout here, step by step. I will just show to you in one example. So, let's see. Condenser sizing. Open. Taking so long. I need to close the other files. Oh, it's coming. Okay, this is condenser sizing. Look at the flow sheet. View. The key to condenser sizing is, let me run this file first. Run. Okay, there's some error here, that's okay. Temperature crossover in this condenser. I don't like that. That's okay, let me show to you. Now, in doing this, you look at this material stream. On the side, there are two outlets. This one is called pseudo stream. On the top is the side product. Why is the pseudo stream? First they recognize 35 stages. 35 stages. You go to the profile, top of the condenser. Stage 2 is the vapor flow. Enter the condenser, stage 1. Why is the flow, temperature, pressure of the stage 2 vapor